All right, here we're discussing rate of change, which is really the same thing as slope, but we want to think about emphasis on change, and the rate, or the ratio of how that's happening. So rate of change compares the relationship of two changing quantities, something that's changing in relation to something else, but they're related. And here units do matter. So for instance, in our miles per gallon example, we have miles compared to gallons, and the farther you go, the more miles you travel, the more gallons of gas are burned. So if we say a truck has 16 miles per gallon, that's 16 miles traveled goes with 1 gallon used, which the rate would be the same as if I went 32 miles and 2 gallons were used. Those would be the exact same rate because we'd have a 32 over 2, which would reduce to a rate of 16 miles for every 1 gallon. Another example would be like exercise time versus calories burned. So if I burn 150 calories in 10 minutes, that's the same rate as burning 15 calories in 1 minute. Obviously, you've burned more if you burn 150 calories rather than 15 calories, but the rate is the same. We would say that's 15 calories per minute. And with rate of change, we're always going to get it to this over 1 value. So if I had 15 over 10, I'd want to divide that and get just a plain old 15. So here's our first example. First, we want to think of what two quantities are we measuring that are changing. So the quantities are gas and distance. Gas is measured in gallons, and distance is measured in miles. So to find the slope, or the rate of change, those are really the same thing. We see that it goes down 2 gallons, so we've lost 2 gallons, so it's a negative 2, for an increase of 100 miles traveled. So that's a relationship or a rate of negative 2 gallons per 100 miles, which would reduce to negative 1 gallon over 50 miles, and that would reduce to negative 0.02 gallons per 1 mile. So what does that mean? It means that we burn 0.02 gallons of gasoline each 1 mile that we travel. So if we want to know the miles per gallon, that's what MPG stands for, that's 50 miles we go per, so the per is always that fraction line, the 1 gallon of gas used. The negative doesn't really make sense when you're talking about miles per gallon. And then that's a rate of 50 miles per gallon. Here's your U-tries. Oh, another example here. My bad. So our final example here, which I hope you've already read, we're comparing the rate of change and the rate, so we're doing this twice, and we're comparing people per year. All right, so people, number of people in billions and number of years is the things that are changing. So we have a change of 0.38. So from this to this is a change of 0.38 in 25 years. And that's 0.38 billion people in 25 years. Now we normalize that or divide it to get 0.0152 billion people in 1 year, which is the same as 15.2 million people per year. For the second time interval, we get a change in people of 0.18 billion people over 25 years, which reduces to 0.0072 billion people per year. So that larger rate of change means that there's more people per the same unit of time per 1 year we're measuring here. So more people in 1 year means a faster growth in the population. And on the graph, that means we're going to have a steeper slope, or the slantiness of the graph is the slope. All right, now we've got some U-tries for you, and we'll see you next class.